Well, thanks for inviting me, and I'll start off by apologising. I'm going to say some of the things that have already been said, so I'll go quickly through the bits that are repetitive. I'm going to come at this as a slightly different perspective, actually. By definition, in my view, there is no such thing as a right conceptual framework. And I think context is everything, and that's really what I'm going to talk about in this presentation. I'll cover a few things. I'll cover quickly what is a conceptual framework, how do they differ from models and tools, how to develop one, and then some of the work on the National Ecosystem Assessment to demonstrate this. But let me say a couple of things at the outset. One is many of the examples we've heard about are conceptual frameworks being used for assessment processes, not for research projects. And there's a formal definition of an assessment process, which is very different from doing a research process. It's about an area that's of broad concern, gathering all the evidence together in a coherent way that answers that broad concern question. And there's a set of rules about assessments, this formal process of assessments, that make them credible, legitimate, and authoritative, which is they're asked by somebody who needs the answer. That's the legitimate bit. They involve all the relevant people. That's part of the legitimate bit. They're credible because they look at all the scientific evidence, and they're authoritative because they involve the right people. But I think for many of the contexts we're talking about here, they're research projects, so they have a much more specific question than the assessment ones. And I'll come back to that a bit later on. But because of that perspective, in my view, just to be slightly provocative, I don't think we should ever operationalize conceptual frameworks. I don't think they should ever be testable. And I think a reason to review them is a very good way of making sure that when you come up with a conceptual framework for a particular purpose, you've thought about all the angles. But on its own, a conceptual framework that just includes all the linkages and everything from everything everyone's done doesn't seem to me to be a useful conceptual framework. So that's my slightly provocative opening, and I'll go on and explain that. So firstly, the difference between conceptual frameworks, models, and tools. Frameworks are conceptual, and they're frameworks. That's what it is. They're about concepts. They're about getting a shared understanding of what these components of a very complex system are. And the framework is what are the set of assumptions about how they relate to one another. And so they only have meaning in context. What is the issue at hand that you're worried about? What's the concern? In contrast, models are there to allow relevant simplifications of complex processes. So these are analytical. They're not just concepts. They're much more specific, and they're used to test assumptions, perhaps the assumptions that are in the conceptual framework. And what models are fantastic for is simplifying things as far as possible, clarifying what matters most, where the uncertainties are, finding out what the most influential parameters or variables might be. And tools are just things that allow you to undertake tasks. So if you have a toolbox that's got a hammer and a chisel and a saw in it, before you get one of those tools out, you decide whether you want to put a nail into this bit of wood or cut it in two. And that gives you the tool. You get out, if you want to cut it in two, you get out the saw, otherwise you get out the hammer. And one of the problems about tools is that you have to be really careful that you've decided what you want to use them for before using them. So they only make sense. If you need the clarity of focus from the conceptual framework, you need the processes and relationships established by the modeling, and then you can start to look at some tools. So actually I stole this slide off Drew Purvis from Microsoft Research just to illustrate that models can come in a very wide variety of forms. It could be something very simple, like I think there's a linear relationship between A and B, between the amount of water that we need and the number of people. And then you can start developing models of various sorts, whether they're static or dynamic, whether they're phenomenological, they're just based on observed patterns, or whether they're mechanistic, you actually understand the underpinning process. There's a whole range of different types of models. And because I stole that off Drew, I'll then do a little promotion for his suite of tools that they've now got on the Microsoft site. So these are a set of tools. If you've got a model, you can go there and get some of their useful tools. So Fetch Climate, for example, is a tool that lets you get climate variability information for a particular geographical area. And you can say whether you want precipitation or temperature. You can say what time period or what spatial scale. That's a tool. You know exactly what you want. This one down here, Fills Back, is a tool that if you've already got some data and a model, it does all kinds of Bayesian statistics or likelihood modeling to enable you